Welcome back to Agentic AI, the future of intelligent systems. In our last episode, we explored the emerging blueprint behind agentic workflows, how thinking, delegation, memory, and execution can be architected to behave more like dynamic processes than static pipelines. But today, we turn the lens inward. Because as AI systems evolve to think and act, the question emerges: how do software engineers evolve alongside them? In the early days of programming, software engineers focused on writing logic line by line, manually defining what the machine should do, when, and how. But as we move into the agentic AI era, that paradigm is shifting. Engineers are no longer just instructing systems, they're guiding entities that think, reason, and act with increasing autonomy. And that raises a foundational question: how does the role of a software engineer evolve when the software itself starts to exhibit judgment? Agentic AI systems are not just code, they are behavior. They adapt based on goals, collaborate across agents, and make real time decisions that weren't explicitly written into the codebase. In this new landscape, software engineering becomes more about defining boundaries than building instructions. It becomes more about architecting intelligence than hard coding output. The skill sets required are changing, not vanishing. Engineers now need to design prompts that encode intent, structure workflows that delegate tasks to agents, and define fallback paths for uncertain reasoning. Just as DevOps engineers once adapted from server maintenance to CI CD orchestration, today's developers will shift from coding logic to orchestrating cognition. A major part of this shift involves working with uncertainty. Agentic systems don't always produce deterministic outputs. That means software engineers must start thinking probabilistically, designing systems that can handle ambiguity, recover from hallucinations, and correct course through reflection or oversight mechanisms. Debugging too becomes less about finding a faulty line of code and more about tracing a reasoning path, memory state, or model interaction. This shift doesn't reduce the importance of engineering. In fact, it elevates it. Engineers become the curators of how AI behaves, ensuring that autonomy doesn't override accountability. They set up memory retention strategies, model routing protocols, cost and carbon boundaries, and safeguards that enforce ethical and contextual guardrails. Agentic engineering also demands a new kind of documentation. Traditional APIs had clear inputs and outputs, but when agents can self reflect, delegate, or evolve behavior, documentation becomes dynamic. Engineers must design interfaces not just for function calls, but for conversations, outcomes, and behaviors that unfold over time. There's also a collaborative dimension. Engineers won't just work with other humans, they'll collaborate with AI agents as creative and operational partners, co designing solutions, debugging strategies with AI copilots, and evolving architectures in sync with autonomous components will become standard. As agentic AI systems scale across industries, the role of software engineering will become less about control and more about collaboration, less about code, more about conduct. It will require systems thinking, behavioral modeling, prompt design, governance awareness, and a deep understanding of feedback loops, not just between functions, but between agents, users, and the world they influence. The future of software engineering isn't disappearing, it's transforming from coders to conductors, from builders to orchestrators of intelligent systems. And as we continue to evolve our understanding of what it means to build with AI, one thing becomes clear: engineers won't just survive the agentic revolution, they'll shape it. Thank you for tuning into this episode. Stay with us as we continue decoding the future of intelligent systems, one layer at a time.